This is the dining table demonstration. We're going to focus on a variety of different facets of applying Solidworks to the furniture industry. As part of the data set, I provided three libraries. The first one is a series of weldment sizes for soft woods and hardwoods. Second one is library features focusing on corners and joining methods for woods. So we have corners, some miscellaneous stuff, splice methods, as well as tees. And then the third one is some smart components which we'll use for mechanically fastening our components together at the assembly level. So let's focus first on working in the part environment, where obviously the real benefit we're getting is with cut list capabilities and so on. In this instance, we've just got a 3D sketch designing the profile of our frame, and then we're using weldments and picking from our stock sizes. You'll see that we have English and metric. The English database is more complete. I haven't put the hardwood profiles in the metric system yet. But you can select from each one of those, and in each one you'll find the available stock sizes for that type of wood. Obviously, there's a lot of benefits working in this environment. The flexibility to quickly come in here and change the dimensions to adjust locations of parts interactively and keep everything in context is really powerful. And again, in combining different materials now in SOLIDWORKS 2010, as well as different profiles for the different wood components. Now, say we want to look at some of these components, and instead of using nails or staples or even just screws, we want to do a bit more of a strengthened joint between them. What we can do is start using these library features to connect parts together. So let's have a look at how we do that. First thing we've got to do is pick our category. So in this case we're doing a T-join. Variety of different sections, categories you'll see here. Domino is similar to a biscuit type join, but it's actually a little rectangular tenon that you insert. Different sizes available. And what I'll do is just specify the geometry to correctly locate it. There we go. And again, you just quickly check on the different sizes, and what it's doing is doing a cutout as well as creating the tenon body as well. And there it is. Or we can use dowels to connect this as well. So let's use dowel pins. We'll try a 4 dowel pin system. So again, we just go through and using the reference information. I've tried to put terminology here to make it as intuitive as possible. And here we can come in and adjust sizes. There's also override dimensions depending on the feature. So for example, when instead of say an inch from the edge, dowel length, we'll make it 1.5, and maybe the diameter will do a 1/2 inch dowel rods. And as I said, there's override dimensions, so maybe you want more of an end gap, and maybe you want 5 millimeters or something. So there's a gap between the rod end and the end of the hole. So just like that, we can come in and implement these construction corners. Now when we go look at the drawing, again we can get a lot of value out of this. The biggest one being the cut list, where we get information. You can see here's the rough cut sizes for the different wood shapes, and the actual dimensions of the stock size, as well as the lengths. And again, we've got detailed views where we can look at how those pins are instanced in the system, as well as overviews with the balloons and everything else. So it's a great environment to get a good idea of what we need to put together our system. Let's go have a look at an assembly now where we're joining those. We've got a left hand and right hand system. We've got these stretches between them and a center leg. Now we've got some really great features with smart components that we can take advantage of. If we turn transparency on, you'll see I've actually already inserted some dowel rods, and there's some auto cuts between the dowel rods and these components. So you insert the dowel rod and it does the cuts for you. So using the smart components, we're going to do the same thing to actually bolt this system together. Now, to make it really easy, what we're going to do is use coordinate systems. So I've set up these smart components in most cases to use coordinate systems, so it's very easy drag and drop. We drag it on and it'll snap to the coordinate system. You then pick the size you want, so we want a 3/4, 5/16. and make sure it aligns to the axes. And we can go do this at all these locations. And just the last one. Okay, so what this is a nut insert that we're going to screw into the wood. And obviously to do that we need a hole pre-drilled. So use smart components and smart features to do that. Now for the feature we just pick the body we're going to apply it to. So this one. Sometimes it doesn't give a preview there, I'm not quite clear on that. So now it's actually done a cut into the wood and you can see it just cuts in there to fully enclose that. Next we're going to put in a threaded insert, and then once the threaded insert is into the nut, we can then get it to auto instantiate a whole bunch of fasteners and even a pocket in this piece of wood. So we'll grab our threaded rod, and again it just snaps onto the coordinate system, aligns the axes, pick our size, we want a 5/16 and I just want it to be 1.5 inches long. Okay, and so same thing with the threaded rod. We can click on the smart features, and what it's after is a face that the pocket's going to be coming from. So we'll pick this face here, and you'll see it's added the fasteners in there flush with that face, as well as put a pocket in there so we can actually get in there and tighten it up and put it all together. And so we can do that for all those bottom locations to fully fasten this whole system together really effectively. And again, you can see we've got the dowel pins at the top and everything else there as well. There's a lot of benefits about even the cutlass and the turtle bomb, but we're not going to worry about that for the time being. We'll look at that in a second. In the second example, I mean. Alright, let's have a look at just before I do that, I just want to close these out before we go to the overall assembly, which is finished. So this is in the leg demo, so we go to the completed dining table and then we'll launch up that one. So you can see here I've got the leg system, which is all assembled, and then we've assembled the leg system to the tabletop. And for that there's this tray system with some rails so it's a fully adjustable system. With the configurations, what I've set up here is different ones we can look at, so we can see it in a retracted position. There's a center insert that goes into the table, so we've got an extended position, and they've also got an adjustable setting, and we've got different display states for some of these as well. So you can see in here there's a rack and pinion system which is driving the sliding out of the leaves, and then there's all these fasteners. And again, we've used smart components for a lot of this. There's the dowel rods connecting in different elements, as well as hole clearances. So let's just go back to the retracted one and hide the tabletop. So you can see in here we've got these holes in this tray which we're mounting to the legs. So to make sure those holes are fully aligned, we use the hole series at the assembly level to correctly position them so that the fastener is always going to go and line up perfectly with the legs. And then these holes are propagated down to the part and are updated in the part drawings. Same things, there's holes in the rails, and we're inferring those rail holes back into this tray surface to get the holes there so we can get the fasteners correctly lined up as well. So it's really an improved way of guaranteeing everything will actually assemble correctly. Let's quickly go back and have a look at the adjustable mode. So in the adjustable mode there's rack and pinion mates, so you can come in here and move the parts together and you'll see it. Sorry, gotta grab it out there. There we go. So it all works quite nicely. So I think it's a nice little demo to highlight a lot of the different capabilities that we have in the demo. Now something else I should mention is, we had all these assembly level features like these pockets, and again we can look at the drawing for this component, and those are all carried back through the part to the drawings, and we can detail those in the drawing. So we've got the holes for the dowel rod and the threaded shaft, the pocket dimensions, and so on. So that's the great integration that we have in Solidworks. So I think this is again a good example to how you apply the potentials of applying this to the furniture industry.